Hello everyone. Today we're going to use two-port parameters to analyze circuits. So the question is this circuit where sections of the circuit are turned into their two-port equivalent, and we know what the G parameter is for this two-port circuit is, and we also know what the H parameter is for this section of the circuit. And what's unknown is all the voltages and currents, given that we know a value for VG is applied to the circuit. So the value is actually 30 volts. So VG is equal to 30 volts. So I'm going to add that right here. And specifically, the question is asking for V out, but generally speaking, we just want to analyze the circuit and calculate all the voltages and currents for the components. Now, like what we said, we're going to treat the two-port models as components and use these equations as for the equations defining the operation of those two components. And for the rest of the components, it's just business as usual. Okay, so let's quickly label the circuit. So assuming that this port, now I'm going to call this V1 and call this V2, and this would be our V out. Now, assuming that this is our ground, this is our ground, this obviously becomes my V1, and this becomes 30 volts. This becomes V2 plus, and this becomes V2 minus. This is V out plus and V out minus. In terms of currents, the current going into the first port, I'm going to call it I1. Now the current going into the second port of this box right here, I'm going to call that I2. Notice that I am always, for these two-port analysis circuits, I'm always choosing the current I1 and I2 to go into the box, and that's just a convention. These equations are valid given that we follow this convention. In other words, the current of the port 1 goes into the positive terminal of port 1, and current I2 for port 2 goes into the positive terminal of that port. Now, when it comes to labeling these two connected to each other, I'm going to have to do the same for this second port and assume that there's a current going in order to directly use the equations. But then, in order to reduce the number of unknowns, I'm not going to call it anything new, because I know if this is a node right here in the middle, I2 plus this other current are equal to 0. In other words, these two are opposite of each other. So I'm going to just call this one minus I2 as opposed to calling it something different. And then writing KCL for that node. And then finally, out here, I'm going to call that I out. Okay. With that, I'm ready to start writing equations. I don't have to write any KCL. There would have been a KCL for this node, but I took care of that. The equation for this component gave me the voltage for that node, and what's left is 1, 2, 3, 4 components to write equations for. And like I said, there's no need for KCL. So we start writing equations for components directly. Equations for components. Now, For the 10 ohm resistor, we have I1 is equal to 30 volts minus V1 divided by 10. For the 15K in the output, we have I out that is equal to V out minus V out plus, which is basically minus V out. So it's minus V out divided by 15K. Now it's time to write equations for the two sections that are turned into two-port models. So for the first one, we use this definition for the equations. So the current I1 is going into the port 1, so I1 is equal to, now it's equal to G11V1 voltage of port 1 plus G12 I2, the current of port 2, this is 2. And the values for G's are given. So G11 is 3 divided by 35. So 3 divided by 35 V1 plus, and the value G12 is 20 divided by 7. So 20 divided by 7 I2. Then V2, the voltage of the second port, is equal to G21 V1, and G21 given as 800 divided by 7. So 800 divided by 7 times V1 plus, now G22 is given as 50,000 divided by 7, or 50K divided by 7. So plus 50,000 over 7 I2. Now, when we get to the second two-port circuit, we have to be careful because this equation down here is written for the general definition of the H parameters, but we didn't necessarily use the same labels for the voltage of the port 1 and the current and voltage of the all the ports there. So we have to be careful and replace V1 with its equivalent, which actually happens to be V2, and I2 happens to be actually I out here, and then I1 is minus I2 and V2 is V out. So we're gonna use those values. So now V1 in our case, okay, be very careful. V1 here is the voltage of port 1 for this two parameter, which happens to be V2. So V2 is equal to, now H11 I1 plus H12 V2. Now H11 times the current of the port 1 in this case is minus I2, and H11 is 5,000. So H11 is 5,000 times minus I2 plus H12 actually happens to be minus 0.2. So minus 0.2 times the voltage of the port 2, which is V out. And finally, the last equation, current of I2, or current of port 2, in this case is I out, is equal to H21, which is minus 4 in this case. So minus 4 times the current of port 1, which is again minus I2, plus H22, which is 210 to the minus 6, which is 210 to the minus 4. So plus 0.0002 times V out, the voltage of the port 2, which is V out. Okay, with this, the equations for components are concluded, and now we can start doing math. So obviously, if you have a good calculator, at this point all you need to do is to just punch in all these equations, and it's going to spit out all the values for voltages and currents. If you want to do it with hand, this is the process that I'm going to suggest. We're going to have to calculate V out. That's what's asked of us to do in the question. So we're going to start removing all the other parameters. We have 6 equations and 6 unknowns, and we just go through the process of deduction. So I out here, for example, defined as this equation. I'm going to take this definition and put it anywhere else that there's an I out, and obviously that's right there. So from this I have I out equal to, so this equation, so 4 times I2 plus 0.0002 V out is equal to minus V out divided by 15,000. So I multiply both sides by 15,000, I get 60,000 times I2 plus, this is 3, so plus 3 V out is equal to minus V out, or in other words, minus 4 V out is 60,000 I2, so V out is equal to minus 15,000 times I2. Okay, so now we don't have I out in any equations. Now next I would use the definition for V2 and put it in this equation or anywhere else that I have V2, and apparently this is the only place where I have V2, so I use this definition and put it in this equation. So I have minus 5,000 I2 minus 0.2 V out, and at the same time I already know what the definition for I2 is. I could have used that, but we're gonna wait for that. Minus 0.2 V out is equal to 800 divided by 7 V1 plus 50,000 divided by 7 I2. Okay, now I'm going to multiply both sides by 7 in this equation, so that would be minus 35,000 I2 minus 1.4 V out is equal to 800 V1 plus 50,000 I2. Now I'm going to move things around, move this to the other side. So minus 1.4 V out is equal to 800 V1 plus 85,000 I2. Now I can actually replace that with this equation. So that would be equal to 800 divided by V times V1 minus 85,000 divided by 15,000 V out. So that simplifies, and I can now move it back to that side, 1.4 V out. So it's 85 divided by 15. So it's 85 divided by 15 minus 1.4 V out is equal to 800 times V1. And now finally I'm going to use this definition for I1, put it back in the first equation, and at this point I already know the way to define V1 as a function of V out, and I know how to define I2 as a function of V out, and that's what I'm going to use. So in other words, I'm going to immediately turn this into this equation. So 3 divided by 35 times now V1. I'm going to use this definition. It's 85 over 15 minus 1.4 divided by 800 times V out plus 20 divided by 7, 20 divided by 7, but this definition instead of, so it would be minus 20 divided by 7 V out times V out divided by 15,000. So now I take this and put it in this equation. So 3 over 35 times 8C5 over 15 times 800 minus 1.4 divided by 800 V out minus 20 divided by 7 times 15,000 V out is equal to 30 minus V1, which is again this equation. It's 85 divided by 15 minus 1.4 over 800 V out, and the whole thing divided by 10. So we have an equation that now at this point is only a function of V out, and from this we should be able to calculate V out. As it turns out, from this V out is actually equal to 3,750. Okay. I hope this has been useful, and thank you very much for your attention.